April 6th, 2011. You guys are on text page 198, Blue Notebook page 178. We're on lesson 4.1. So today we're going to be talking about vertex form, okay? That's why it was important that you guys got this down in your summary. We dealt with vertex form in the very first chapter, if you guys remember, okay? They had given us, oh, I changed everything. They had given us our vertex form. Which was f at x is equal to, now I wonder what coloring I used. I'm going to make sure it's, all right, so we got the right colors down that we used from before in the first chapter. Our vertex form is f at x is equal to a times x minus h n bracket squared plus k. So if you guys remember, all of these variables represented something when we were drawing a parabola. Our a had to do with the stretch factors. So whether it was compressed or whether it was stretched by a factor of whatever number a was. Our h had to do with moving the vertex left and right along the x-axis. So if it was positive h, do you guys remember which way it would go? To the left. It would go in the negative direction. And if it was negative some number for h, which way would it go? To the right. Good. And finally, k had to do with the vertex moving up and down. Okay, so on the y-axis, if k was positive, it moved up, and if k was negative, it moved down. So that part made sense. What we're going to deal with today is moving from vertex form to standard form. So standard form is our f at x is equal to, and I'll get the other things in here in a second, plus x. We'll do our colors. Again, we have an a. Now, these a's don't necessarily mean they're going to be the same number, okay? We use that letter to represent them in both equations. And finally, our c, okay? Our standard form. So we're going to work on, when we have an equation in vertex form, changing it into standard form, and then finally, going into factored form. So this is why our last couple of chapters were so important to know. X minus, we just used R and X, right? I don't think I gave it any colors. And A, okay? I don't think I gave those colors. I didn't want to confuse you. So today, our goal is to get an equation in vertex form, change it to standard form. Once we have it in standard form, we're going to once again change it to factored form. We have to be able to make the connection. So when it's in vertex form, we know we're able to find the vertex of a parabola quite easily. And when it's in factored form, we know we're able to find the zeros or the x-intercepts quite easily. Okay? So that's why we're doing these steps. So we can graph every part of a parabola that we need. So we'll start with vertex form. We're going to go right into example 3, I think, in your textbook, okay? So we'll go to example 3. Okay, so here's our example 3. They've given us the number 3, which is, in our theoretical model, our a. So that would be the factor of what this vertex, or sorry, this parabola is stretched by. Our 5, or negative 5, represents our h. So remember, if it's negative 5, our vertex goes to the right 5. And finally, our k is represented by positive 7. So we know that vertex is going to go up 7. Okay, so we know that about the parabola, but what I actually want to do is I want to move this equation into standard form. So what I'm going to have to do is I'm going to have to expand and then simplify to get it into standard form. So because we have our brackets, according to BEDMAS, we deal with our brackets first. Inside our brackets, I have x minus 5. That's as simple as it gets. There's nothing else I can do there. So next step I do is exponents. I have an exponent to this bracket. So when I go to rewrite this, I don't just bring the exponent inside. What that means, if you guys remember, is we double up the base of the exponent. So this then becomes x minus 5 times x minus 5. That's where we're using our FOIL again. That's what we did in our second chapter. Okay? So I've expanded this, and then we're going to go into FOIL. So I'm just going to use the equal sign now. We'll leave f of x out. So when I go to FOIL, I do my first terms. X times x is x squared. Then I do my outside terms. X times negative 5, negative 5x. Inside terms, negative 5 times x, hey, same thing. And finally, last terms, negative 5 by negative 5 is positive 25. So I've now FOILed our brackets. I'm going to simplify this bracket now. Once again, we repeat BEDMAS. So I go back inside these brackets. Negative 5x minus 5x is negative 10x plus 25 plus 7. Next, I deal with our multiplication. I need to distribute this 3 to each number inside of the brackets. 3x squared minus 30x plus 75 plus 7. And finally, I'm going to simplify my last two terms. 3x squared minus 30x plus 82. Hey, and now we have our standard form. A, B, and C. So if you guys take a look, I've now moved I can't quite get it all on one screen, but here was our vertex form that we started with. This was our vertex form. From there, we moved all the way down to here, and this is now in standard form. To get to standard form, all we did was expand and simplify. So you guys notice these line up the same. 3 is, look at that, still our A. B is negative 30, and C is 82. Okay? So we now have moved to our standard form. That's great. Whenever I represent a quadratic expression, that's what this is, right? Quadratic field parabolas. If I ask you to represent a quadratic expression, usually I want it in standard form unless I say otherwise. Okay? Now, the other thing we had learned is we know how to go from standard form, like we said, to factored form. So in order to do that, we're going to have to factor this equation. So I'm going to take this equation again, rewrite it down here. Very first step, I look for a, oops, that's the wrong number. Look for a common factor. Is there a common factor here? No. 3 would be the only number that comes out of the first term, and it does not come out of our C, our 82. So we go straight into finding the factors of our first one, 1 and 3. Factors of 82, that's going to be quite a few numbers. 2, and we know that the product has to add up to negative 30. Okay? 2 and 41. That might be one that works pretty well. Let's, we know 3 doesn't go in. 4. No, that's right. 5, does 5 go in? No. The 6. No. 7? Yeah? How many times does it go in? No, 7 does not go in. 8, 9, 10. Now, we're running kind of scarce right now, so let's just go with what we have. Looks like none of those are going to work. And also, if I do 9 times 9, I know I'm at 81. If I do 10 times 10, I'm at 100. So I've exhausted all my options. Once I got up to 9 and 10, none of those numbers went into this. Those times themselves, 10 times 10 is greater than 82, so I've exhausted all the options. These are the only factors I have. So we're going to try what we normally do. We're going to multiply across. So our 1 times 1, 3 times 82. You guys think that's going to work? I don't even know what that is. 6, 240, yeah. Don't even bother. We know that one's not going to work, right? Let's cross instead. 3 and 1 and 82. Do you guys think that's going to work? No, that does not work at all either. We're not going to get a combination of negative 30. All right, let's try 6, 41. Uh-oh. Is this going to work? No. Okay, so when we looked through these, we discovered that none of these are going to work this way. Later in the chapter, you guys are going to learn how to factor a quadratic like this, but we were not able to get whole numbers for the zeros. So that means the zeros of this parabola won't be whole numbers. So let's go back to what we have and try to use the information we have above to graph this. So first thing we do know, actually we'll do this in red. Things we do know about this parabola. We know that this parabola vertex is going to be where? To the left, to the right 5. To the right 5. So what is the x-coordinate going to be of that? 5. What is the y-coordinate of the vertex going to be? 7. Good. R. Thank you. Thanks, Jay. All right. So our vertex is 5 and 7. We do know that. Okay. So we take that information. We are unable to find this here, what our zeros are. There is one other thing we can find that we haven't tried yet. Does anyone know how I could find the y-intercept of this? Sorry, right here. Y-intercept. What variable can I manipulate? X. What would I make X? 0. That's right. If I make X 0, I can then find out what the y-intercept is. So let's take this original one, our vertex form, because that's going to be the easiest to manipulate, okay? So I'm going to go back to the bottom again. I'm going to take our original one. It was f at x 3 minus 5 squared plus 7, right? All right, so if we make our x equal to 0, because we know on a graph that's where our y-intercept is going to be when x is 0, and we're going to plug that in. 0 minus 5 squared plus 7. Negative 5 squared plus 7. What's negative 5 squared? 25. Good. Keep writing the wrong numbers. Oh, geez. No, we didn't do the first one. All that we found out is we're unable to factor it the way we used to. So we couldn't go any farther. Okay? Times 25 plus 7. And this becomes 75. That's why I wrote 75. What's our answer? 82. 82 is our y-intercept. Do you guys remember any other numbers being 82? Yeah, when we went into standard form, our C is 82, okay? That is always going to represent our y-intercept, okay? Because as long as there's an x attached to these, when I substitute x for, or 0 for x into these two, it's going to get rid of them. 0 times, or 0 squared times 3 is going to be 0. 0 times negative 30 is going to be 0. All I'm going to be left with is my 82. So by looking at these, I was able to find the vertex when we're in vertex form. We were able to figure out that our vertex was at 5 and 7, looking right here, 5 and 7. And if I look in my standard form, my C is going to represent my y-intercept. So my y-intercept is equal to 82. Or we could write it at 0, 82 is our y-intercept. So we have quite a bit of information. Let's try to graph this. Pause that there. So we're about to come to an epiphany about our factored form. You'll see what I mean. So our vertex was where? At 5 and 7. So we're going to assume it's going up by 10s. It's roughly there. Where's my y-intercept? 0 and 82. So we're looking at something like that. Now finally, does this parabola open upwards or downwards? Upwards. We do know that. So especially because this is at 5, we know that this is our axis of symmetry here. So over at 10, I'm also going to be at roughly 82. Okay? So when I go to draw this, oh, that was, sorry, my dexterity isn't great here. Okay, that's roughly our parabola. Hopefully you can draw it a little nicer. What about our factor form? Did I find any x-intercepts? Are there any x-intercepts? So does that make sense to why we weren't able to factor this? Yes, there's no x-intercepts for this parabola. We were unable to factor it. It makes sense. So when we our factor form, when you can't find those factors, we're going to learn another style. I'm going to give you an actual formula eventually. And that one will prove to us that there is no x-intercepts. The best thing we could do here was graph the information we had. So I'm giving you a lot of info right now. To myself. All right, text page 204, number 4. I want you guys to work on that for the next about 10 minutes, okay? Number 4.